So basically what's happening here is we have two blocks and they're on top of each other. So when block A is pushed in this direction, the block B is going to move up. And there's friction in between the surface right here, between A and the horizontal surface. There's friction between the surfaces of A and B, and there's also friction between B and the vertical surface. Now the mass of A is 3 kilograms and the mass of B is 5 kilograms. So basically what we want to do is we want to determine the Cartesian component equations of motion for A and B, and then we want to use those to find the acceleration of A and B. So obviously A is going to be accelerating in this direction and B is going to be accelerating up when A is pushed this way. So in this question, it's going to be useful to separate both of the blocks and draw two free body diagrams, and then you can draw the Cartesian component equations for each block and then solve both of the equations. So the first thing I'm going to do is draw a free body diagram for both of them. The hardest part of this question is just considering all the forces that are acting on the block because there are so many. So the first thing you want to consider is the applied force, which is 50 newtons. The second thing we want to consider is the normal force between A and the horizontal surface. And then there's also the force of gravity, don't forget that. Then there's also a normal force in between A and B. So block B is going to be exerting a normal force on block A. Now this normal force is perpendicular to the surface, remember. So we'll call this we'll call this NAB for the normal force. Now, since block A is going to be accelerating in this direction, there's going to be a force of friction acting in the opposite direction on the horizontal surface. So we'll call this FA. Now, remember that block A and B are rubbing against each other. So since block A is moving along block B in this direction, there's going to be a force of friction acting in the opposite direction. Now this force of friction, remember, is going to be along the surface of A and B. So we'll call this the friction of A and B. And then also we can write down that the acceleration of A is in this direction. So now I'll draw a free body diagram for block B. Now, the first thing I'm going to do is consider the normal force that A is exerting on B, which is perpendicular to the surface, A and B. Now, the vertical surface is also going to be exerting a normal force on block B, so we'll call this NB. And we also need the gravity acting on block B. And of course, let's not forget the friction force that's acting in between A and B. So also don't forget the friction force that's acting on block B from the vertical surface. So since block B is moving up the wall, the friction force is going to be acting downwards. So now that we have our free body diagrams, we can write out our equations. So in the x direction, so for block A, we can start off with the x direction. So the first force we have is the 50 Newton force, and this is acting in the positive x direction. Then we have the friction force of A and the horizontal surface, which is acting in the negative x direction. Now also in the x direction, we have FAB and NAB, except these forces aren't acting exactly in the x direction. They're acting at an angle. So we're going to need to figure out whether to multiply this by cosine or sine of 15. Now we can use the same trick that we used before, where we just draw this coordinate plane. So now that we've drawn our two coordinate planes, we know that this angle right here is 15, and this angle right here is 15. So in the negative x direction, we have NAB multiplied by the sine of 15. So we also have negative FAB multiplied by the cosine of 15. So in the y direction, we have the normal force acting in the positive y direction. Then we have the force of gravity acting in the negative y direction. And then we also have the normal force of AB and the friction force of AB, but we need to multiply those by the angles as well. So in the negative y direction, we have NAB multiplied by the cosine of 15. And in the positive y direction, we have FAB times the sine of 15. So since we're trying to find the net Cartesian equation component equations for the x direction and the y direction, we need to make sure that we consider the acceleration of the block. So in the x direction, A is moving positive because A is moving to the right. So therefore, there's acceleration in the x direction. So that means that all of these forces equals the net force. And the net force is also equal to the mass of A times the acceleration of A, if you remember Newton's first law. Since block A isn't moving in the y direction, the equations in the y direction are going to equal 0. So now we can do the same thing for block B that we just did for block A. So first let's figure out the angles of these normal forces and these friction forces. Okay, so now that we've figured out which angle the normal force of A and B and the friction force of AB are acting, we can write out our equilibrium equations. So in the x direction, we have positive FAB, so FAB times cosine of 15. Then we also have positive NAB times sine of 15. And then in the negative x direction, we have NB. Now in the y direction, we have NAB acting in the positive direction. We have negative FB. We have the force of gravity as well acting in the negative direction. And finally, we have FAB acting in the negative direction as well. So since block B is just moving up the wall, that means the acceleration of B is just in the y direction. There's no acceleration in the x direction. So our y forces are going to equal the net force, or the mass of B, times the acceleration of B. And the forces in the x direction, those are just going to equal 0. Okay, so now that we've finished writing out our equilibrium equations for block A and block B, we can eliminate a lot of unknowns by using the simple friction equation. Now, the only issue is that we only have 4 equations, but we have 5 unknowns. So that means that we need at least one more equation to figure out what all of these unknowns are. So one way we can create more equations is by using relative motion. So I'm not going to waste your time by going through relative motion in this video. You should watch my other video if you want to learn about that. But the relative motion equations will simply look like this. So you can get the 6 unknowns you need since you have 6 equations by using a matrix, but I won't waste your time doing that, and I hope this video helped you a little bit to understand friction. And if you have any questions, feel free to leave them in the comments below.